Next, I want to get into the map method, and this one is a lot of fun. As I start to show in the book here, I start with a list called strings right here, and then I note that in these two lines here, a for loop and a for each method call are equivalent, these two examples that are shown. So I do for every string in strings, do this print line statement, and that's the equivalent of calling strings.forEach and then passing in this anonymous function right there. So that makes you wonder, is there an equivalent for this for expression? So here I have a for expression where I'm saying for each string in strings yield string.length. So that creates a new variable here called lengths, which is derived from this input list of strings right here. And it turns out, yes, there is an equivalent for that, and that's called the map method. So with map, we do this right here. We say for the strings list, call the map method, and then get the length of each element, and then return those as lengths right here. This is easier, just go ahead and show in the REPL. So let's just copy that, and we'll go over here and paste that in. The first example looks something like this, where it said val lengths equals, and then this is my for expression. So I say for string in strings yield s.length, and that creates that right there. Similarly, I can do val lengths equals, and now instead of using the for expression, I just do the map. So I say map, and just to be explicit here, what's going on here is I can say for each string, do this algorithm, string.length, return the string length. So that gets me the same list here as I had with that for expression. So here this is an anonymous function, and as I mentioned, it's being very literal, or it's a long form or a literal form of this. So I'm saying for each string s in my list of strings over here, return s.length, which is the length of each string. And as I mentioned in most of my writings, you can think of the map method as being named transform, because you're literally transforming this list right here into some new list over here with the algorithm you supply. So if you ever have trouble with map, there's two ways to think about it. One is that it's the same as a basic for expression like this. And the other is that you can think of the name map as meaning transform, because you're transforming each element. And in that example, I showed the long form, but in Scala, we typically would just say underscore dot length. So in this case, underscore is a placeholder for all of this stuff right here. And the reason that works is that the Scala compiler is very smart. You don't have to, you can actually, gosh, back in the old days, maybe when I first started working with Scala, I would actually type in things like this. I would say, for each string s, which had the type string, go ahead and give me the string.length. And that's really a horribly long form of typing this. You know, nobody wants to read that much code. And the cool thing is Scala is very smart, and it says, well, there's no reason to declare that this is a string right here, because I know that it's a string from when you declared the list way up here. So instead of typing this, you could just type this, or in Scala, you just type that. And one other thing I'll mention, since I am showing this long form, is when I read this to myself or as I'm typing it, you may have heard me say, for each string s in strings, do this algorithm right here to transform that string into something new, which in this case actually is an integer. And then the cool thing is that the map method itself here actually implements a for yield loop for you. So you only have to worry about transforming one element at a time using your algorithm inside here. And because map has a for yield loop implemented internally, it actually transforms every element for you. The map is actually really interesting. It can be used in many ways. So let me create a new list, and we'll make it a vector this time instead of a list, just to show you something new. So I could say big belly burger is this new vector, and it contains those three strings. And so what I did in that previous example was I did something like this, where I said x of s.map, and then for each string, give me the string length, and then I reduced that to just this code here. So that gives me the lengths of all the strings. So here, wouldn't it be cool, instead of having the lengths here as these integers here and then having the strings up here, wouldn't it be cool if I could return both of those into the same variable over here? And in fact, you can. So this is a good place to say, for every string, what I want you to do is return a tuple, a two-element tuple. So I want you to return both the string, and then I want you to return the string length like that. And when I hit enter, you'll see the result. So you can see this is a vector that contains tuples. So each tuple has two elements. The first is a string, the second is an int. So then when we come over here, we can actually look at the data. So here's our vector, and the first element in the vector is this tuple. So it contains the string big, and that's 3 characters long, and belly is 5 characters long, and burger is 6 characters long. So that's really cool. We combine the length, the string, and the length of the string in each element. And another really cool thing is I could have done that in a function. So let me create a function. And I will say, what do we call this one? Just to goof around, we'll call it string length. So we will take a string as an input parameter, and then we're going to return that tuple, right? So we're going to return a tuple that contains a string as the first element and an integer as the second element. And then the body of the method is just going to be what I had above. So it's going to be a tuple, and I'm going to return that string as the first element, and then the string length as the second element. So that's my function. And now I can go back up here and say val length equals xves.map. And instead of putting an anonymous function in there, I can actually put this real function in there and put in string length like that. And then I get the exact same result as before. So I showed a couple things in these last 2 examples. One was, instead of doing a simple transformation like I had done here before, I made a more complicated transformation where I turned this string here into a 2-element tuple here. And I did that here as an anonymous function. And then I did this a second time by creating a function that does the same thing here and then passing that function in right there. And there's many different ways to show that type of functionality. So I could say, let's say I had a list called x of s, which would be a list of 1, 2, 3, 2, 3. And then I could say val y's, or the doubles. Whoops. And doubles equals x of s, and then I could say map, or again transform. So I want to transform each element multiplying by 2. So in that case, I passed in this anonymous function that doubled each element. And this particular example would be longer, but I could say create a function that doubles an integer. So I could say I colon int, and then I times 2. So that's actually now a function named double. And so then I go back up here, and instead of passing in that anonymous function, I could pass in the double function. And I kind of skipped over how that actually works. So a longer form of that would be taking each parameter I and then transform that into the double of I like that. So that's a longer form. And that can be more clear, especially when you're first working with Scala. It can be more clear to write it like this. So you're saying this anonymous function is to transform every integer I into its double. But with Scala, you don't have to type all these extra characters. You can just do this. And an intermediate step I could have done would have been to type in this. Oops, not that, but this. So this is the what I would call one of the long forms. This is slightly less long, and then this is a preferred form for this particular example. And one thing I've kind of glossed over in these examples that I want to make a little more obvious right here is that when you write a function like this one here, the input parameter to your function here, this type, int, needs to match the type that's in the list here, which is int. And that's because when you write x of s.map, and then you're saying I, go over here to double the I, this parameter here is being passed into your double function. So again, just this double function needs to take the same type that's in this list right here. Now the return type over here can be anything in the world that you want for your algorithm. So let me just hit return there and then go back here. And then this one, for instance, could be a double. And then I could say multiply that by 2.2 or something like that, just to be different. And now when I go back to the x of s map call, instead of returning a list of int as I do here, now the new double function returns a list of double here. So all I'm trying to emphasize here is that this return type can be anything you want it to be or need it to be. One other thing to mention is how the map method works with a map class or map data type. So here I have a map of states, where I've intentionally done these in lowercase. So I just have the two states, Alaska and Alabama, and their abbreviations. So their abbreviations are the key here, and then this is the value over here. So this is one element in the map, essentially, is the key pointing to this value. And a second element in the map is this key pointing to this value. And now when you call the map method on the map type, usually what I do is I'll say something like this. I'll say, I want to create an uppercase version of that map. So I want to say map, states.map. And I'm going to put an extra space here just to be explicit. So what you do is you're going to work with the key and the value. I'm going to put those together again, just to be clear. So for each element, for each key value pair in this map, I want to transform that into a new result. So I will call that new result, first time I'll just return the key, and then I'll return the value, and then we'll say to uppercase. And again, another blank space just to give us some more breathing room there. And so what you can see in the result is that I didn't do anything with the key here. So the key here is lowercase and the key here is lowercase. And for each element, what I did was I changed the value to be uppercase. So that's why this one's uppercase and this one's uppercase. And similarly, I could have made both of them uppercase to uppercase. And I can just tab that over like that. And now you see that result there. So this is the technique for using the map method on a map data type. And the key for the solution is just knowing that for every iteration in the loop, there's basically a for yield loop behind map. So for every iteration, you're going to have a key and value pair shown here. So you specify those as K and V over here. You don't have to call them K and V. You can call them anything you want, but you specify those as a 2-element tuple right here. And then you say you want to transform that. And you could transform it into anything you want. I just happen to be transforming it into another tuple over here and another tuple down here. And just to stress that last point, you could actually write your own keys method like this. So you could say states.map, and you don't really need that spacing that I showed before. So now you can do key and value. For every key and value, just return the keys. All right, so that ends up creating this list of the keys that are in the map. And that's what I mean by your algorithm can transform this into anything you want. You need to take the key and the value as inputs as a tuple, and then you can transform that into any algorithm you want, like that one, or this one, or this other one. And now to give you a little idea where the map name comes from. In this example, I had shown that I started off with this list of strings here, which was these list of strings. And then I converted that into a list of lengths by using this map call here. And that ended up giving me this list of integers. And so where the name map comes from is I show right here in this area here, is that you're actually mapping an input to a new result or a new value. So A maps to the number 1, and BB maps to the value 2, and CCC maps to the value 3. So in the field of mathematics, what you literally do is you say, I have a set over here of these values, A, BB, and CCC, and then these values map to these other values, these other ints over here, given the length algorithm. So they actually literally use the word map when they say A maps to 1, BB maps to 2, CCC maps to 3. So that's where the name map comes from.